Hello you guys, this is Lexi and my presentation is on metal 3D printing. So here are some contributors for the 3D printing. It starts with Charles Hall, who is the guy in the upper left corner, and he was credited towards being the inventor of 3D printing in general. In 1986 he was awarded a patent for stereolithography, which is a method of 3D printing that uses UV to harden the material. In 1987 he invented the first printer, which was the SLA-1. And he also is the inventor of STL files, which is what you save a CAD file as to put it into a slicing program. Next we have Scott Crump, and in 1989 he invented fused deposition modeling, which is a method of 3D printing where they use polymers as filament, which is extruded using heat. This is the basic method of 3D printing that most of us are already familiar with. If you're trying to print something out of plastic, it's what most 3D printers use or similar to what they use. Next there's Dr. Hans Langer. He invented direct metal laser sintering, which is using a laser to make a workpiece out of a powder bed. It's really similar to the first method, which is stereolithography, the only difference being Charles Hall used UV light instead of the laser. In 1991, Eli Sachs created binder jetting, and it's a machine that would jet an adhesive into a powder bed to make all that stuff stick together and to create the part. And next we have the process of 3D printing. So first you have to have an STL file, so you can grab that online. Something that you can use is GrabCAD to find free files that you can grab, but most companies will end up making their own, so you can use SolidWorks, Solid Edge, whatever CAD software you want, make whatever you want, and then you have to save it as an STL file. The next step is to convert it into a G-code file. So in the upper right corner, it is a screenshot of Cura. Somebody was making something. So these slicing programs, you use it to lay out your print bed. You can duplicate stuff. You can size stuff to whatever size you want, scale it down. And then you also select what percent infill you want, what speed you want it to print it at, and all the settings that you select will overall impact the strength and integrity as well as the quality of the print. Next you got to prep the printer. So this includes leveling the print bed and loading the material. And the last step is to print. So most metal printers use something similar to direct metal laser sintering or binder jetting, where somehow a powder is used and that is clumped together, whether it be through laser UV light or through adhesives, and that's usually how it's made. But it is possible to do it through the standard method, which is similar to fused deposition modeling, where you just heat it up and extrude it out of a nozzle and just keep working on it. And next we have limitations. So first limitation is size. Most 3D printers aren't huge, so they can't be used to make large pieces. If you want to make a really large 3D printed thing that you can't fit on the print bed, you'll have to print it in sections at a time and figure out a way to fuse that together. The next limitation is cost. So reliable and reputable metal printers can cost anywhere from $100,000 to a couple $1,000,000. And then even after spending that much money on the machine itself, it's about a couple $100 for a spool of metal that you can use to actually print on it. So it's not exactly feasible for hobbyists to use or own. Another one is time. 3D printers are notorious for taking a ton of time to make the smallest parts, because in order to get a good quality workpiece, you have to go really slowly. The faster you go, the messier it'll look, and it won't be very good, which brings us into the surface finish. So to your right, I have a picture of a 3D printed part. As you can see, you can see exactly where the nozzle has been and where it's going to go. You can see all the patterns, and in some pieces it's not going to work out and people aren't going to want something with that kind of surface finish, but also in other pieces it's totally fine to have a finish like that. So it just really depends on the application. And here are the applications. So for applications I have hearing aids. I don't have a picture of that, but Sonova, a Swiss company, started using 3D printing to make custom-made hearing aids. So they did this by I think pouring silicone into the ear and then using that as a basis for a model and then printing it out of metal. It can also be used for cranial implants. So with this, you can custom mold a metal printed implant to a person's skull, so if they have to remove it or anything, and it can be screwed in. And then it can also be used for turbine blades. So this exact example that is shown here is the GE Aviation. They printed turbine blades for their GE9X. It can be used for other things as well. There are many other applications. Basically, whatever you can think up, it can be applied to. So here are my sources, and thank you guys for listening to this presentation.